So, good morning, sir. This is Dana Paso, and I'll be going to present my third examination, which will be I'll be going to illustrate the simulate actually the synchronous counting of the seven segment display on the process that has or that we'll be going to use as well the flip-flop IC. Okay, while using or while going to simulate the said circuit, I will be going to guided with the documents that was being uploaded on the LMS. So basically, here is the problem statement. So first, we'll be going to use the one button only to trigger the system. The second one is that we'll be going to use the flip-flop IC, and in my case, I'll be going to use the 74HC74 flip-flop IC that will also as the counting the circuit with 4 bits binary output. And the ICs for decoding the binary output of flip-flop to decimals. Basically, we'll be going to display the 0 to 9 digit number, and when it comes to display the 9, we'll be going to make a condition on the flip-flop IC so that it will be going to has a continuation of counting from 0 to 9, and then 9 back to 0, then back to 9. So now we'll be going to simulate the said circuit, and in this time, I'll be going to choose for the the gates or the materials that we'll be going to use in the said circuit. So let's start. So for me to start on providing or simulating the said circuit, we'll be going to use first the logic state, and with the inverter, the AND gate, the OR gate. Basically, we're going to use the OR with has 4 tails, and the OR gate that has a 3 tails. And also the IC that we'll be going to use, which is the flip-flop IC, which is 74. A button that will triggers the display. Uh, this time I'll be going to use the green one. So let's start the simulating. You might be flip-flop IC, but don't worry because we'll be going. There's a reason why I did that. Okay, so first we'll be going to simulate the the flip-flop IC or the flip-flop IC circuit. So this will be connected to the circuit that will be going using the K map or the equations that we have got in solving the K mapping. So here, and also there will be a need for us to use the DC clock here. We'll be going to inject that one here so that our system will be going to work. So since we're already simulated the flip IC circuit, now we're going to move on in simulating the actual circuit. So here, so we're going to use the logic state before we're going to remove this later on, and we're going to substitute the flip IC circuit that we've already simulated. So here, since we've already simulated the binary or the inputs, so we now going to use inverters. This will be your observation for the primes, snap for the primes, this will be A, this will be A, primes, so restoration system, that's going to be easy, that's circuit. You're going to rotate the side this side. And we're going to this. Also this. And that's it. We're going to this one. Here. Just going to be inverters. That makes sense. So in my case, I use this type or this kind of design for me to avoid on having a longer single circuit. So second shot, messy. So, well, so just think those. Yeah. Yeah. So provided this equation, we need to simulate the set. Or remove the gears. Yeah. So now we're going to start and simulate. After simulating uh, the circuit using the logic state and also the K mapping through K mapping, we have here and to test if this specific circuit that I have simulated using the K mapping values or the K map values that we've got from the table will work. So we'll be going to start system and we'll be going to start the input of the inputs. So zero, we have zero. We're starting the zero display. Using the input of zero, the input, the zero. And for us, we have the one. We have here D. Always with one here D. Okay, so two, three, we have four, and five, five, six, seven, there's eight, and nine, and we have here, and now we'll be going to stop the system because we'll be going to 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 put the flip-flops instead of having the logic state. Okay, for A, we're gonna connect this. For D, okay, for A, this is for A. Then we're going to connect the second flip-flop at B. The third one will be here. And here. And lastly, here. And we'll be going to remove the logic states because we have already have the here the flip-flop IC circuit. Okay, so we'll be going to start that one, and we'll be going to click the button. Basically, it starts and counting, and let's just wait first until it reaches to the 9. Okay. Okay. So basically, it will continues to a different display. So what we're going to do is that we'll be going to apply in NAND gate for us to put a condition in this part. So that is why I put a this because we have to do something on this part. Okay, so we're going to put the NAND gate, and as we all know, this is the ground, so we'll be going to connect that into the ground. So for us to achieve the only for us to display only 0 to 9, we need to put a condition in this part. So basically, for us to achieve, basically this is my um, this is my documentation, by the way. And let's just see here. Okay, so if we're going to have 1001, this is where we can to have the zero again continuously after the 9, we need to achieve the 000. And for us to do that one, we need to connect this other here. We need to connect that here, and also this one to here. And the NAND gate as the condition to the IC of the to the flip flop IC circuit. Now we'll be going to simulate and start our system. But first, let's go ahead and turn off the button, and let's see if does this circuit will work, especially in achieving the display of having 0 to 9 and 9 to 0 and asynchronous counting of 0 to 9 back to 0 to 9. And basically the counting starts at 1. Let's just wait. Okay, perfect. So by having the 9 and by having the NAND gate as connected to the flip of circuit as a condition, as you can see that from after 9, it will came into 0. Okay, so basically this specific circuit does achieve the simulation of binary to 7 segment display decoder of the 0 to 9 counter using flip-flop IC. And the one that I'm being used here is the 748C74. So that's all, sir, and thank you for watching.